All right, let's talk about something you probably learned years ago and maybe haven't thought much about since: slope. It turns out this simple idea from math class has a secret identity, one that helps us understand, well, pretty much everything that changes in the world around us. So, what is this big secret? Let's dive in. You know this formula, right? I bet you've calculated it 100 times. Rise over run. You plug in the numbers, get an answer, and move on. But have you ever really stopped and asked yourself what that number, that slope, is really telling you? That's the question we're going to unpack today. Because as soon as you step out of the classroom and into the real world, slope puts on a new costume and gets a much more powerful name and a much more important job. In math class, we call it slope, and it's all about how steep a line is on a graph. It's kind of abstract, but in the real world, in physics, in finance, even when you're just driving your car, it's called a rate of change. It's the exact same math, but suddenly it has a whole new layer of meaning. And here's the key. Rate of change isn't some brand new, super complicated idea. Nope, it's just slope, but with units. That's it. Suddenly, we're not just dealing with numbers, we're dealing with feet and hours and dollars and gallons. And you know what? To unlock this entire concept, to be able to look at any slope in any situation and know exactly what it means, you really only need to know one single magic word. Yup, that's it. Her. This one little word is the bridge that connects the number you calculate to the story that it tells. If you don't remember anything else from this explainer, just remember the word per. So let's reframe how we think about this. We're not just finding a number anymore. We're finding out how much the y thing changes for every single 1 unit of the x thing, the change in y per 1x. And you already use this concept all the time without even thinking about it. Your speed? That's just a rate of change, miles per hour. The price of something at the store? That's a rate, dollars per apple. Your paycheck? Dollars per hour. See? It's literally everywhere. Okay. Theory is great, but let's make this real. We're going to walk through a couple of examples, step by step, to see how this actually works in practice. Let's start with a hiker. We've got some data here showing their elevation in feet at a few different times in hours. Our mission is to figure out their rate of change and, more importantly, what it means. We're just going to follow a simple 3-step process. First, we do the math using our trusty slope formula. That gives us 500. Second, we gotta identify our units. What are we measuring? Well, the y-axis is feet, and the x-axis is hours. Third, we put it all together with our magic word. And there it is. That's our story. The number 500 isn't just a number anymore. It means that for every single hour that goes by, our hiker gets 500 feet higher up the trail. It's a clear, simple interpretation. See how that works? All right, let's try another one. This time, we're draining a swimming pool. The slope's already been calculated for us. It's -50. And our units are gallons and minutes. So, what in the world does that negative sign mean? We use the exact same process. We've got our slope, -50. We add our units, gallons per minute. Now we just have to interpret that negative sign. If a positive slope means something is increasing, well, a negative slope has to mean it's decreasing. So, here's our story. The pool is losing 50 gallons per minute. Now, notice how we say that. We say it loses 50 gallons, not that it loses -50 gallons. That's a common little trap we'll talk more about in a second. Okay, for our last example, let's say you're comparing 2 different subscription plans. Plan A costs $10 per month. Plan B costs $20 per month. Pretty simple, right? But which plan's cost is climbing faster? Well, a bigger rate of change just means a steeper slope on a graph. Since 20 is bigger than 10, the cost of Plan B is rising way more quickly. Even if Plan A had a huge startup fee, that higher rate of change for Plan B means it's going to eventually cost you more in the long run. Now that you've got the main idea down, let's quickly go over a couple of common mistakes that can really trip you up when you're just getting the hang of this. First, always remember the order. Slope is rise over run, right? Change in y over change in x. So that means the y unit always comes first. It's dollars per hour, never hours per dollar. Second, watch out for that double negative. Saying something decreases by -50 is just confusing, and mathematically, it actually means it increases. Just say it decreases by 50. Simple, clear, and correct. So the big takeaway here is that this isn't just a math problem on a test. Once you know what you're looking for, you'll start to see rates of change absolutely everywhere in your daily life. Let's make this super practical. Let's say you just enjoyed a 250-calorie donut. And now you're wondering, how long do I have to run to burn this off? Guess what? That's a rate of change problem. So first, you need your rate. Let's just say you burn about 100 calories every 10 minutes of running. We can simplify that down to a rate of 10 calories per minute. Then the math is easy. You just divide the total calories in the donut by your burning rate. 250 divided by 10 gives you 25 minutes. See? This stuff gives you real predictive power. So there you have it. We've revealed slope's secret identity. It's not just some random number you calculate on a graph. It is a powerful tool for telling a story about speed, about growth, about cost, a story about how everything in our world changes in relation to something else. So I'll leave you with this one question to think about. As you go about the rest of your day, what's one rate of change you're going to notice? Is it going to be the speed of your car in miles per hour, the price of coffee in dollars per cup, or maybe how many text messages you send per minute? Once you start looking, I promise you'll find them everywhere. Thanks for tuning in.